Okay, ladies and gentlemen, we are getting into volcanoes. So this is lesson number 6, volcanoes. We are going to talk about different types of volcanoes and different classifications of volcanoes and different volcanic rocks and where volcanoes happen. So that's what today is all about. So in your notebooks, the challenge question is, what are the 3 types of volcanoes and how do volcanic eruptions vary? Um, I am going to mix in the vocabulary as we go instead of just doing a straight vocab section. Okay? So when we talk about volcanoes, there are 3 different classifications. You Volcanoes can either be considered extinct, dormant, or active. So extinct volcanoes, if you look, are not expected to ever erupt again. We don't think they've erupted in human history, and because they are so old, we don't have evidence to suggest that they are going to erupt again. So there are multiple examples. I gave 2: Mount Thielsen in Oregon in the United States and Mount Slemish in Coantrum, okay, which is a different country. So those are both examples of extinct volcanoes that are there, but we don't expect them to ever erupt again. Now, a dormant volcano hasn't erupted for at least 10,000 years, but it could erupt again. So 10,000 years is approximately human history, where we've been recording events in human history. And these volcanoes, humans have not seen them erupt, but they have potential to still erupt again. And 2 examples of those are Mount Kilimanjaro in Tanzania in Africa and Mount Fuji in Japan. So those are both really big mountains. They're big volcanoes. We haven't seen them erupt, but they could potentially erupt again. The ones that you are the most familiar with are the 3rd classification, and those are your active volcanoes. Those are most of the ones that you know about. So active volcanoes are currently erupting right now, or they're showing signs of erupting, or they've erupted at any point in human history. So those include Kilauea in Hawaii. Kilauea has been erupting consistently for about 10 or 11 years now. Mount Etna in Italy, close to Mount Vesuvius in Pompeii, if you did that with Mr. Giorgiani. Mount Stromboli is also in Italy, and it has been erupting almost constantly for the last 2,000 years. So that is a lot of erupting. And we'll get into how that could be. So I wanted to show you a world map of where these volcanoes are happening. If you take a look, the solid black lines are our plate boundaries that we've been talking about. The black squares are major cities in the world. The yellow, and we'll get to those later, yellow squares are earthquakes. We're going to focus on the red squares. So if you notice, the red squares are volcanoes. And for the most part, they occur on or very close to plate boundaries. You do have some outliers, okay? There are some additional weak spots in the plates. Sometimes they're called hot spots, where there are cracks in the plate and it allows the magma to come up to the surface. But for the most part, they're on these plate boundaries. So if you look right here, Greenland is this country right in the middle of the mid-Atlantic ridge. Um, did I say Greenland? I meant Iceland. I'm sorry. Iceland is right here. Iceland is being pulled apart literally by this divergent mid-Atlantic ridge, and it's allowing that magma to come up to the surface. It has very volatile volcanoes. The United States, we only have volcanoes. We see them on the western coast, right next to the boundary between the Pacific plate and the North American plate. Um, on this boundary that is actually covered up by the earthquakes and volcanoes, this is this was on our map that I showed you the other day. In Africa, close to this plate boundary, here is a very tectonically active portion of the world. And there are a lot of active earthquakes and volcanoes. And I want to point out this section right here. See how half of it is here? This is the western part of the Pacific plate, and here is the eastern part of it. So if you can imagine that coming up, I'm going to give you a different look right now. That same section, here's your Pacific plate, North America, Japan, Asia. This is known as the Ring of Fire because it is so tectonically active and there is lava being pushed up from almost that entire perimeter. The one exception to that is right here. Do you know what this is in here? That's Hawaii. So Hawaii are volcanic islands, and there's a hot spot in the middle of the Pacific plate where that magma pushes up through, and that is what has created and is currently still creating Hawaiian islands, and that's where those come from. Okay, so when you hear the Ring of Fire, it's just this plate boundary that's, slightly circular in nature where we see a lot of volcanoes. Okay, so let's talk about the different kinds of eruptions. When we talk about volcanoes, we'll use the word magma if we are talking about liquid rock underground. And then once the magma comes up to the surface, we call it lava. When a volcano erupts, it can either be explosive, it can be non-explosive, or it can be a combination of the two. So depending on how much gas is trapped inside of that lava will depend on how big the explosion is going to be. Explosive lava tends to be really thick and full of all this bubbly gas, and the less explosive lava tends to be a little bit more runny and thinner and slower. Okay. All right. So what causes a volcano to erupt? So I'm going to read this to you, but rock from subducted plates melts to form molten magma, which pushes its way toward the surface, forming a magma chamber. Gases that have been dissolved in the magma expand, causing a massive increase in pressure. This increase in pressure causes the magma to rise and force its way through the cracks or fissures in the volcano above. As it reaches on the surface, the pressure is released and an eruption occurs. During an eruption, volcanic ash, rock, dust, gases, and lava are all ejected. How violent the eruption is depends on the amount of silica present in the magma. Silica produces a thicker magma that is better at trapping gases. The more gas present, the greater the pressure. Therefore, the more silica present in the magma, the more violent the eruption will be. Okay, so think of it like a pop bottle, right? The more I shake a pop bottle, and the more that carbon dioxide builds up in the bottle, when I unscrew the top, it all comes shooting out. The foam, the pop, it runs down the side, very similar to a volcano. So the more gas you have inside that rock, the more it builds up. And then when it finally does blow, you have a bigger explosion, a bigger mess, okay? A less gassy or like flat pop, if you can think of a flat bottle of pop, you can shake it all you want, but it's not going to foam when it comes out because it doesn't have that CO2 in anymore. That's very similar to a less gassy magma. So if I'm looking at a less gassy magma, it tends to ooze out of a volcano and roll down the side. A lot of times it's very slow. You can walk in front of it. This is on Hawaii. You can actually go to parts of Hawaii and it's so slow that the top of it will start to cool and harden into that hard rock, but it's molten inside. Super hot still, very, very hot, still very destructive. It's just because it is a little bit slower, you can often get out of its way, okay? I would say that they are a little bit less dangerous. When you are talking about gassy magma, you have these explosions. And that's where the top blows off of the volcano, or the whole side of the mountain will blow off. And there are cases where the entire volcano blows itself up and then the volcano isn't there anymore. It creates what's called a pyroclastic flow, which is this giant cloud of toxic gas and heat that moves very fast and can knock down trees and incinerate anything in its way. So this is very dangerous. So in a in an explosive eruption, the pyroclastic flow would come first, followed by the magma. And then usually that magma can run for quite some time. Okay, so we can break down volcanoes into 3 different types based on their shapes and eruptions. The first type is a shield volcano. They're very large, very broad. See how wide this one is. It releases fast moving, less gassy magma. So not very explosive. The lava rolls down the side and it creates a smaller elevation. They tend to have a lot fewer explosive eruptions. The second type is called a cinder cone volcano. And cinder cone volcanoes are the smallest. They have this nice crater on top. They pop up sometimes rather quickly. They're very common. They have explosive eruptions though, so they will often shoot lots of gas and rock high above them. And they often form on the sides of other volcanoes, where you'll actually have you can have a big shield volcano, and then on the side there's a small cinder cone volcano that'll pop out of it. The third type, and this is the most dangerous of the 3, is a composite volcano, and it's also called a stratovolcano. It's a combination of the both. So it's very broad because whenever it has less gassy explosions, that magma rolls down the side and it extends very far, but it also has explosive eruptions. And so those blow the tops off and create that cinder cone shape. So they have a little bit of both. And this big mountain is often formed by different layers of the lava and the ash kind of laying on top of one another. This is your Mount St. Helens. This is your, I'm trying to think of some other famous ones that you would know. Mount Kilimanjaro is a stratovolcano. Mount Vesuvius. These are the big ones. Okay? So the cool thing about the lava is when it hardens, what do? You get rocks. So depending on what kind of eruption you have, that will determine what kind of rocks you make. So if you have less gassy magma, you are more likely to make basalt rock. This is a basalt rock. It's kind of black. And there are different versions, but in general, this is a basalt rock. It's the most common rock on Earth. If it cools slowly, this is what you get. If it falls into the water and it cools really quickly, it doesn't have a chance to crystallize, you get obsidian for my Minecraft people. Obsidian is basalt that just fell into the water and it cooled very, very quickly. Same components though. If I have more gassy magma, I get what's called pumice. Pumice is a type of volcanic rock. It might look like something you've seen in a neighbor's yard. There's red lava rock, they call it. People use it for landscaping sometimes, but it has those tiny little holes, and the holes are made from the gas bubbles. So whenever the volcano erupts, it kind of is frothy. The lava is pretty frothy. And when it hardens, it turns into pumice. Okay, and the pumice forms when it comes into contact with water, and so you're going to find pumice most often near volcanoes close to the water or under the water. Okay, so that was a lot about volcanoes. I'm going to give you some videos that you can watch and get some extra information. So go ahead and follow those links. Okay, all right. Thanks, guys.